Today we're going to be finishing up section 7.1, talking about confidence intervals, specifically those involving proportions, and then also looking at sample size and some more examples. Okay, so in order to talk about sample size, you should still know the same notations that we've used in the previous class, and so you can read through those if you need to. Okay, so we have two sample size formulas. The first formula is occasionally there has been previous studies that can allow us to have some kind of estimate for p hat. So if there's a previous study giving us an estimate for p hat, then we're going to use this formula here. So we're still going to use the same critical value just like we did for our margin of error. We're going to need our p hat and our q hat, and then our e is our margin of error is our e. So that's what you're going to be looking for there. When there is no estimate known, so maybe you have no previous study to draw from, then you're going to use this formula here. So the 0.25 is actually basically an estimate of whenever you're estimating p hat to be 0.5, and that means q hat would be 0.5. So 0.5 times 0.5 is actually 0.25. So when we don't really know anything to indicate any other way, we just kind of assume that p hat and q hat are both 0.5, and therefore this would be replaced with 0.25. Okay, so these are easy problems, but they're missed a lot, and it's simply because people don't recognize the type problem that they are. So these are going to have some keywords like how many or find the sample size, and that's going to be the indication that you're going to need to use one of those two previous formulas that were on the previous slide. Another word that's going to be important for you to look for is the word within. If you see the word within, that's a keyword to indicate that they're giving you your margin of error that you're going to need for the problem. Okay, so when we do sample size problems, we always have to round up to the next largest whole number. So even if you have something like 1067.11, then that looks like it would round down, but for sample size, it always rounds up. Because if our calculation says we need this as our sample size and we round down, then we are not going to be able to maintain the level of accuracy and confidence that we need in our problem. We're always going to round up to the next largest whole number. Okay, so here's an example. When the author was conducting research for this chapter, he could find no information about the percentage of adults who make online purchases, yet that information is extremely important to online stores as well as brick and mortar stores. If the author were to conduct his own survey, how many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? Okay, so a couple things here. I see the word how many. How many is telling me that this is a sample size problem. It in the first part here it says assume that a recent poll showed that 80% of adults make online purchases. So we do have this prior information. So that tells me I'm going to use the n is z alpha over 2 squared times p hat q hat over the margin of error squared. Okay, so this is going to be my p hat. My p hat is the estimate that's known from the prior study. So q hat is going to be 1 minus p hat. So 1 minus 80 or zero point 0.8 is going to be 0.2. So p hat will be 0.8 and q hat is going to be 0.2. Okay, so I'm basically ready to go with this except for the margin of error. And here it tells me that it's in error by no more than 3 percentage points. So 3% is going to be my margin of error. I do need to convert that to a decimal. So 0.03. So I want to be 95% confident. So that's an indication of my confidence level. So for 95%, hopefully you remember that the critical value for 95% is 1.96. P hat is 0.8. Q hat is 0.2. And the margin of error is 0.03. The number one mistake I see people make is dropping this little square here. So make sure you keep up with that square. Okay, so when I put that in my calculator, I get 682.951. And the number 2 mistake I see people make is giving this as their answer and forgetting to round up. So we want to round our answer up, always up, and it's going to be 683. Okay, the next one here, we're going to be working with the same scenario, except this time we're going to assume there's no prior information. So if we have no prior information, we're going to use the formula z alpha over 2 squared times 0.25 divided by the margin of error squared. So again, this is a 95% confidence, and so I'm going to replace my z alpha over 2 with the critical value for 95%, which is 1.96 times 0.25. And then my margin of error, again, is that 3%, so 0.03 squared. So when I do that, I get 1,067.11. We will round that up as we said we always do and get 1,068. So one thing I want you to keep in mind is that when you have no prior information, that's always going to require us to have a larger sample size because you don't get to build on something that's already been done when that happens. It's important to keep our sample size as small as possible. So we don't want to just say, oh, we're just going to do 10,000 when you don't need to do 10,000 because there is a lot of cost associated with gathering this data. So if we can attain the confidence level that we want by working with a sample that's 1,068 instead of maybe 5,000, then it's important to do this calculation to know how many do we have to have in order to have that level of confidence. Okay, so I've put together a few extra practice problems for all the material in section 7.1, sample size, and also doing the confidence intervals themselves. So what I would like for you to do is on the first one here, I want you to actually just do these using your calculator. So I don't want you to work it out and show me all the work. I want you to practice putting it in your calculator and then answering the follow-up question to that. So pause the video and then check your work with this. So in this one, since it's only asking for you to use your calculator, you just need to identify the important information. Your sample size is going to be N. This is going to be your X, and then there's your confidence level. So I'm going to hop over to the calculator and finish this problem. Okay, so we're going to go to Stat, over to Test, down to 1 proportion Z interval. We're going to enter for this one 580. For the X, and for the N, 765. Couple reminders, X always has to be a whole number, N always has to be greater than or equal to X. Okay, so we're going to keep it at the 95%, and we're going to calculate. And so here is our interval that we're going to have. So 0.728 to 0.789 for our answer. Okay, so 0.728, and then that's going to be 0.789. Okay, so when you do these on your calculator, I'm not expecting to see the margin of error calculated and all those different things. Okay, the second part, using your answer from part A, if voting records show that 61% of eligible voters actually did vote, are the survey results consistent with actual voter turnout? Why or why not? So to be consistent, 61% would need to be in this interval that we constructed. 61% would not be in that interval, and therefore it is not going to be consistent with actual voter turnout. So this is another one that I want you to specifically put in your calculator to answer. So go ahead and identify the N, the X, and so forth, and put it in your calculator and try to answer these questions. Okay, here, this would be our N. This is our N. It turns out that they're giving us our P hat. So in order to find our X, we're going to do N times P hat. So that's going to be We're going to multiply the 3005 times 0.817. So we're going to find that our x is 2455. And that's actually the answer to part A. How many of the 3005 subjects use at least one prescription medication? So that's going to be 2,455. So if you put that in the calculator, you'll put this in for the x, the n, and then we're doing a 90% confidence interval on this one. So when you put that in, you end up with this as your interval. Okay, so that's our 90% confidence interval estimate. What do the results tell us about the proportion of college students who use at least one prescription medication? Actually, on this one, it tells us nothing, because this is talking about people that are age 57 to 85, and we can't extrapolate results from one age group to another age group. That's not a valid technique to use with sampling and confidence intervals and so forth. So we want to make sure that we're not trying to transfer results from one age group to a different age group there. Okay, here we have a sample. Well, I'm going to let you work on 3 and 4 and see what you get for your answers, and then you can check your work. Okay, on this one, how large of a sample is necessary to estimate the true proportion of unmarried Americans from ages 25 to 29 within 2.5 percentage points with 90% confidence? So I'm looking for keywords. So here's how large. That tells me it's a sample size problem. And I also see the word within, so that tells me it's a margin of error there. So I'm going to use this one. I don't really have any previous information that's given, so I'm going to be using this one. Okay, so for 90%, I'm going to put in 1.645. And then for my margin of error, 2.5 percentage points. So 2.5% is going to be 0.025, and that's going to need to be squared. So I'm going to get 1,082.4. And we talked about you always have to round these up. So 1,083 for my answer there. Okay, for the next one, from a previous study, so since I have something prior to build from, I'm going to use this formula. Okay, so it is believed that 25%, so that's going to be my p hat, of U.S. homes have a direct satellite television receiver. How large? That indicates sample size. How large a sample is necessary to estimate the true population of homes which do have a direct satellite receiver with 95% confidence within 3 percentage points. So here's my margin of error using the keyword within. So I'm going to use 95% tells me I'll use 1.96 for my critical value. My p hat's going to be 0.25. My q hat would be 1 minus that, or 0.75. And then my margin of error is going to be 0.03 squared. So I'm going to get 800.33. So I'm going to round that up to 801. Okay, last example here I'd like for you to try on your own. This one I do want you to show your work, so I want you to show calculating the margin of error, calculating the confidence interval. I want you to go through all the steps with that one. Okay, so this one you've got an n here and you've got an x here that's given. So in part A, it says give the best point estimate. So our best point estimate is p hat, and p hat is x over n. So that's going to be 856 over 1228. And that's going to give me 0.697 for my best point estimate. So I want to calculate the margin of error for a 90% confidence interval. So my margin of error is z alpha over 2 times the square root of p hat q hat over n. So I'm going to have, for a 90% confidence interval, I'm going to substitute 1.645. My p hat is 0.697. Q hat is 1 minus that, which is 0.303. And then my n is 1228. So my margin of error for this one is 0.216. Okay, we want to estimate the true proportion of medical malpractice lawsuits that are dropped or dismissed by giving a 90% confidence interval. So we're actually ready to do the p hat minus the error and p hat plus the error. Okay, so p hat in this case we said is 0.697. We're going to subtract from that the margin of error that we just calculated. Remember that we don't put anything substitute in the middle here, and then we'll add for the endpoint here. Okay. So here we'll have 0.675 and 0.719. Okay, also notice that we always build our confidence intervals around the population, around these unbiased estimators. So here we have an unbiased estimator of p hat. P hat is an unbiased estimator of the population proportion p. So what we do is we take that unbiased estimator and we add and subtract our margin of error to it. And when we do that, we generate the confidence interval around that. So for the interpretation statement, we would say we are 90% confident that the interval from 0.675 to 0.719 actually does contain the true value of the population proportion of medical malpractice lawsuits that were later dropped or dismissed. So that would be the statement that we would have there. Okay, I'd like to end by showing you on StatCrunch how you can actually do this type of confidence interval. So I wanted to take a minute and show you here on StatCrunch how to do this. So if we go to Stat and Proportion Stats, we're going to choose one sample. And for now, we're going to do with summary. Okay, so for the one that we just got finished doing, our number of successes, which was our X, was 856. Our number of observations, or that's our N, would be 1228. We were doing a confidence interval, and that confidence interval was 90%. So if we compute, then you're going to see here is the confidence interval that we were able to calculate ourselves. So hopefully you can see it now. So that's just an easy way you can also do these on StatCrunch.